This event is not a myth. It occurred during a controlled test flight involving an Israeli Air Force F-15 Eagle in the early 1980s. The aircraft returned to base, missing almost the entire right wing. The landing was real. The aircraft was repaired and flown again. The F-15 is a twin-engine air superiority fighter with a large wing area and powerful engines. It was never designed to fly with one wing missing. The survival of the aircraft depended on physics rather than luck. The incident began during a dissimilar air combat training mission. The F-15 was maneuvering against an A-Force. During a high-angled turning fight, the two aircraft collided. The Skyhawk struck the F-15 on the right side. The impact sheared off most of the wing from root to tip. The F-15 pilot initially believed he had suffered minor damage. The aircraft remained controllable. There was no immediate roll or uncontrollable yaw. This delayed the realization of the actual structural loss. The wing did not fail catastrophically because the F-15 generates a large portion of its lift from the fuselage itself. At high speed, the body acts as a lifting surface. This is due to its flat underside and blended wing body design. Lift is not produced only by wings. Lift is produced by airflow deflection and pressure differentials. At sufficient speed, any surface with the right angle can generate lift. The remaining wing and fuselage compensated through increased angle of attack. The engines played a decisive role. Twin Pratt & Whitney engines provided enough thrust to maintain airflow over the airframe. Thrust vector alignment helped counter asymmetric drag. The pilot increased speed to maintain control authority. Roll control was partially achieved through differential thrust and stabilator input. The remaining wing generated lift, but also induced roll. The flight control inputs balanced this instability within a narrow envelope. Fuel imbalance became critical. Fuel in the missing wing was gone. This shifted the center of mass. The pilot had to manage throttle and attitude precisely to avoid departure from controlled flight. The aircraft could not slow down normally. Reduced speed would have caused immediate loss of lift. The landing approach was flown at unusually high speed. Flap deployment was limited to avoid further asymmetry. Ground crew were unaware of the extent of damage. The pilot declared an emergency but did not specify wing loss. The visual confirmation came only after landing. During touchdown, the aircraft required a long runway. The pilot maintained high speed until the final moments. Aerodynamic control diminished rapidly after touchdown. Braking was applied carefully to prevent yaw. The aircraft stopped safely. Inspection revealed that more than 60% of the right wing was missing. The wing root had absorbed the load without complete structural collapse. This incident demonstrates that modern fighter jets are energy machines rather than fragile air. Design margins exist far beyond normal operational limits. These margins are intended for combat survivability, not training collisions. The F-15 structural design emphasizes redundancy. Control surfaces are oversized. The fuselage is load-bearing. Engines are powerful enough to substitute for lost aerodynamic efficiency. This event does not imply that fighter jets can routinely land without wings. It occurred under very specific conditions. High-speed clean configuration, favorable mass distribution, and immediate pilot response. At lower speed or higher damage asymmetry, the aircraft would have been lost. A single-engine aircraft would not have survived this scenario. This case is studied in aerospace engineering and military flight safety. It reinforces that lift generation is distributed across the airframe. Wings are primary, but not exclusive contributors. The pilot did not perform a miracle. He stayed within physical limits. The aircraft responded according to aerodynamic law and structural resilience. The jet was repaired using a replacement wing. It returned to operational service. The airframe life was not immediately ended by the incident. This landing remains one of the most extreme demonstrations of aerodynamic survivability in combat aviation history. It is not a stunt. It is a documented outcome of design physics and controlled execution.